Okay, I'm going to show you how we can get the expression 5 cos theta minus 12 sine theta into the form r cos theta plus alpha. First thing to do is to expand the right-hand side. So we know that r cos theta plus alpha is r cos theta cos alpha minus r sine theta sine alpha. Okay. Then we're going to look at the left-hand side and the right-hand side and notice that we've got a term in cos theta on the left and a term in cos theta on the right. So we're going to equate those two terms, and the coefficient on the left is 5, so we've got 5 cos theta, and the coefficient on the right is r cos alpha. Similarly, we've got terms in sine theta on the left and sine theta on the right, and again if we equate the coefficients we've got that 12 is equal to r sine alpha. Notice that they're both negative, so we can just ignore the negatives there. They can cancel out. Okay, so we've got two simultaneous equations in r and in alpha. We solve those following this method, so we're going to start off by finding out what r is, and to do that we're going to square both expressions. So from the first one, we have that 5 squared is equal to r squared cos squared alpha. And from the second one, 12 squared is r squared sine squared alpha. Okay, so if we add those two expressions, we're going to add these two, we're going to have that 5 squared plus 12 squared is r squared into, now I've taken out r squared because that's multiplied by both of those terms, into cos squared alpha plus sine squared alpha. I'm sure you've all recognised that cos squared alpha plus sine squared alpha is an identity that we already know, that's equal to 1. So we're just left with 25, 5 squared is 144, which is 12 squared, is equal to r squared times 1. So 169 is r squared, so r is 13, square root of 169. Okay, so we found out what r is. Now we need to come back to our original equations up here and work out what alpha is. Now, to do that, we write one of the equations on top of the other, and it makes sense to write them this way up. You'll see why in a second. So we've got r sine alpha, which is equal to 12, over r cos alpha, which is 5. So we've got that equation. On that, the r's will cancel, and we're just left with sine alpha over cos alpha, which is, of course, tan alpha, and that's equal to 12 over 5. So alpha is going to be the inverse tangent of that, which from our calculator we get is 1.18 radians to 2 decimal places. Okay, I'll just move that out of the way so I can just show you that the answer to 5 cos theta minus 12 sine theta is going to be r, which is 13, cosine of theta plus 1.18 radians. Okay. Now we're going to have a go at another one of those. This time we've got 4 sine x minus 8 cos x, and this time we've got a sine in where we had a cosine before, and we've got a minus here. Now we could have used cosine here, and if we use cosine here we'd have x plus a. We want the signs to match basically to make it easier. Okay, so again we're going to expand that, so we're going to have r sine x cos a plus r cos x sine a. Don't miss this expansion line out, because that's where people tend to make mistakes if they don't do the equating thing. Okay, so again we're going to equate and get our two equations. So we've got 4 is r cos a and 8 is r sine a. Okay, so we're going to do the squaring thing again. So again we'd have 4 squared is r squared cos squared a, and 8 squared is r squared sine squared a. Okay, now this thing of when you add them and you get the cos squared plus sine squared, which is equal to 1, happens every time. So we can skip that stage after a while and just say that 4 squared plus 8 squared is going to be equal to r squared. So that's 16 and 64 is r squared. So r is going to be the square root of 80, which simplifies to 4 root 5. Okay, again, we need to write our sine on the top, so we're going to have r sine A over r cos A is equal to 8 over 4. So tan A is 2, and A this time is 1.11 radians from the calculator. So just move that up a little bit and put our answer in. So 4 sine x minus 8 cos x equals 4 root 5 sine of x minus 1.11 radians.